In this tutorial video, we'll show you how you can use some basic features of the HashMap class from Java library. So before we begin, if you want to see the complete documentation for HashMap, what you can do is open your web browser and go to the search engine, and then type Java API and then HashMap. If you hit the search, simply look through the latest version of the Java, for example, version 8. If you go there, and then you can see the complete documentation for HashMap. Okay. And then we're going to go over some of the methods or constructor for the HashMap with you in the JUnit test. But if you want to see other methods for complete usages, you should really go to this web page and then see over there for the documentation for the class. And also you can see also the summary for all the available constructors and also the summary of all the available methods. Okay, this is really the authoritative guidance for you to consult with if you really get stuck with your application. But we're going to show you the common usages for HashMap back in Eclipse. Okay, let me switch back to Eclipse. So I do have a small JUnit test method to go over with you. At the same time, I'm also going to use an iPad to visualize how things work at the runtime. Of course, in the Eclipse, I will also use the debugger feature to go execute the code line by line to see how we can explore the runtime object structure. Okay, so now before we begin, let's just review very quickly what a map is. The way you can one way to understand what a map is intuitively is basically like a two-column table, something like this. Basically, you have a table like this, and then you have two columns over here. You can, and then the left column is called the key, and the right column is called the value. And then you can have as many rows as you like. You can have one row over here, two rows, 3, 4, and 5, 6, as many as you like. So your table can be as large as you might need for your application. So intuitively, a hash map is simply a collection of entries. Okay, and what each entry is contains a key and a value. You can see we've got a key and we have a value. And now it's really important to note the keys over here for the left column over here are used for search purposes, which means if you want to identify a particular entry in your current map, you must use a key to search for that particular entry. And since it is going to be used for search, there cannot be any duplicates for the key. Otherwise, given the same key value, it might identify more than one entries in the map, so you got ambiguity over there. Okay, so now keys must be unique. Okay, so these are the critical points about the map before we go over the code. Make sure you understand that, or you can review your lecture notes or background material before you go on. Okay, let's go back to our code over here. So what I will do is I will put a breakpoint at the first line for the test HashMap JUnit test method. Okay. Before I execute the code, let me just go over some syntax with you over here. You can see it is an assignment over here. On the right hand side, we have a new keyword, which means we are trying to assign the address of some new objects to some variable. And here we declare a variable called grades over here. And then the type of the variable is called HashMap over here, HashMap. And let's try to understand what's the syntax over here very quickly. Okay, let's go to iPad over here. So let me just repeat whatever declaration it is over here. So we have HashMap. So this is the type of the variable you're trying to declare, and every collection class in Java is generic, which means you can choose what type of elements or key or value you would like to store in the collection. Okay, so this is the syntax. It has to be an angle bracket to start with. Okay, it must close this element type by a right angle bracket, so it's a matching pair. Okay, in the case of the hash map, you have to separate the type for the key. So this is the type for the key, and the second type you're going to pass is the type for the value. Okay, one for key and the other one for value. Okay, in our case, for illustration, we simply say the key is simply a string, let's say student's name, and also the value is going to be some double value. I'll explain why it has to be capitalized in just a moment. The value, let's say grade point, let's say A plus corresponds to 9.0, and then A, let's say B plus corresponds to 7.5. Okay, it's a double value. Okay, so now let me just put it down. So string over here is going to be the key value, which means all the first column values over here will be just a string value. Okay, for example, it could be, let's say, Hyang over here. It's a student's name. And then the second one over here, let me use a different color here. So the second one here, let me put double here. Okay, and then it can simply be some double value. Let's say Hyang got A+, so that'll be 9.0 over here. There's a particular entry in the map. So now, why do we put double here as opposed to just double? Okay, let's review this very quickly. We know that there are two kinds of types in Java. This kind of a lowercase type is called primitive type. And then the capitalized type is called reference type. And the critical difference is, whenever you talk about primitive type, you just talk about their value. For example, if you talk about 9.0, it's just the value 9.0. But a reference type over here is like especially for double here, is so-called a wrapper class over here. It's a wrapper class for the primitive double value. It's very easy to understand. So the way I create a double over here is to say double, I can say D is assigned to, let's say, new double over here, and then I can simply pass, for example, 9.0. This is how I create a new double objects. Okay, so at the runtime, it's simply going to be D is pointing to some double objects over here, and then it has some value field over here, and then it's going to be the value of 9.0. You can see we wrap this particular value called 9.0 inside an object. That's why it's called a wrapper class. Okay, so very quick illustration. But in Java, they actually got something very convenient for you. When you are expecting a double type over here, what you can do is you can pass directly a value like a 9.0, even though it's actually just double type. Okay, so it's very easy to convert between double and double. Okay, for example, 9.0. Okay, you can just use them quite seamlessly, as we'll see in the tutorial video. This is something called boxing and unboxing. So I wouldn't spend too much time on this for this tutorial, but if you're interested, you can simply just go Google and then try to see what boxing and unboxing, what they really mean. Okay, but we'll see lots of instances for boxing and unboxing in this tutorial video. Hopefully you will get some feel. Okay, one more thing to say. Okay, so whenever you're trying to specify some element type for Java collection, make sure you always specify a reference type. This is why I'm using capitalized double reference type rather than lowercase double for primitive type. Okay, if you simply put double over here as the value type, it's not going to compile. You should always put a reference type. Okay, but of course, if you simply got a type called person or the point, there's no issue. I'm just saying for primitive value, you should always put the corresponding wrapper class. Okay, let me just maybe summarize that for you, just in case you have doubts. For int, you can put integer. Okay, for char, you can put character. For bool, you can put boolean. And also, as we have seen, if you have double, you can simply put double. So these are the primitive type, and these are the reference type. Okay, reference type and primitive type. Okay, make sure you understand those. Okay, so now let's go back to our again. So this line, what I have done so far is just to illustrate to you how you can understand the syntax. HashMap, left angle brackets, right angle brackets, and then you put reference types over here. The first one for the key, and the second one for the value. Okay, just make sure you understand those. Okay, before we actually try to illustrate to you how it works at the runtime. What I would do is, okay, I already put a breakpoint at the first line of the JUnit test. So what I would do now is I'm going to launch the debugger. So I can simply click on the bug button here, or I can simply right click on this test HashMap JUnit class, and I can say debug as JUnit test. Okay, once I do that, it's going to switch to the debug perspective. Okay, and make sure, let me just delete the previous one, the previous expressions I got. I can say remove all. Okay, and then do not ask me again. I can say yes. Okay, so now make sure you have these two panels before you continue. You've got something called variables, which will show you all the variables that have been declared so far. And also the expressions for all those variables declared so far. You can try to manipulate their values to see if their return expression value makes sense. Okay, so these two panels are very, very useful for debugging purpose. So if you cannot see these two panels in your Eclipse, what you can do is you can go to Window and Show View, and then you should be able to see expressions and variables. Just click on them, it's going to be brought to your Eclipse. If you cannot see those two in this drop-down menu, you can just go to Other, and then you can search for them. Okay, either way. Okay, so now at the moment we don't see anything in the variables simply because we are only pausing at the beginning of this line. So that means we haven't created this grades hash map just yet. So what we'll do is we'll say like that. Okay, as soon as I say step over, it's going to actually go to line number 15, which means we have already executed line number 13. If you click on grades over here, you can see there's simply something like a curly brackets. So that's the convention for showing a hash map. So curly brackets, and later on, as soon as we add in more entries, it's going to be like a pair using round parentheses. We'll see that. But what I would like to show you is like this. Let's go to iPad over here. What we have done so far is we have created a non-empty. We have created an empty map. So let's see how we can understand it. So what I would do is I'll draw over here. So we have grades, which stores the address of some table over here, and for the table, what we have over here is we have key and we have value, key and value. Okay, at the moment it's not a single row or single entry that's being added, so it's simply just empty. Okay, so that is why, and let's remind ourselves again. For the key, that will simply be a string, and for the value, it will simply be a double. Okay, just remind yourself. Okay, as we add more entries, this table will be grown. Okay, one by one. Let's go back there. And then the first one, first assertion we're trying to check is assert true, grades not equal to null. This is simply true because you can see from here, we do have something to show you at the variable section. That means the object does exist. And also you can see just that it currently is empty. So do distinguish between being empty and also being null. They are different. Being null simply means the object does not exist. Being empty means the map does exist, it just has no entries inside. Okay, it's different. So now if you say grades not equal to null, and also you can see since grade points to somewhere, okay, so that means it's not null, it's just empty. So if we're going to pass this assertion because grades is not equal to null, so we're going to pass it. So if I say step over, that was going to be fine. And there's one method you can call on hash map, just like how you can call an array list. So grades.size will just tell you how many entries there are in the current map. In this case, we expect to see 0 because it's not a single row just yet. Okay, and then what we'll do is let's check to see. So there are two methods you can call. One is called contains the key, and the other one is called contains the value. Contains key simply means we're going to search through the first column over here to see if there's any key value that we are passing. For example, Alan. In this case, Alan does not exist at the left column, so it's going to return false for this expression over here. We can try copy this expression here, go to expression here, and add new expression, paste. It's going to be false. If we try to add a negation over here, explanation mark, it's going to not false, will be true. So that means assert true is going to pass. Okay, and then we have the second one, similar idea. Contains value is going to search through all the values in the right column over here to see if there's any value with 7.5, which corresponds to B+. Okay, in this case also no, because there's no entry whatsoever just yet. Okay, that's why we also put explanation mark to say grades dot contains value 7.5. If you also copy this expression here and put it here, it will be just false for now. Okay, but as soon as we add in the corresponding entry that says Alan is 7.5, these two expression value will become true. Okay, it really depends at which point at the runtime you're evaluating the same expression. Okay, so now let's see how we can do some insertion into the map. Good. Let's just go step over over here. Okay. So this is the most one of the most critical methods for you to know how to use for map. So it's called put, and then the first element over here is going to be the key, and you can see that ln over here is a string value which corresponds to the string type for the key, right? And also 8.0, you can see we don't have to say new double and then 8.0. We don't have to, so we can just pass 8.0. It's something called boxing, which means we're going to box 8.0 into a reference double objects and then pass it. Okay, that's something Java will do for you. But for you as a user, you just have to know they actually do some very seamless transition between primitive double into reference type double. Okay, so now 8.0. Okay, so now we are saying that ln is going to be of getting A for the grade, so just 8.0. Okay, so now as soon as we hit this line, try to execute this line by saying step over, what's going to happen conceptually? Let's see, and then we'll verify that by the debugger. So now if we say grades.put, let me put it here. Let me use a different color here to illustrate. So now let me put it here. Okay, to avoid confusion here, why don't we put it here? Actually, just that'll be good. Okay, so now the first one, where we say, I'll put it here, grades dot put, and then I say for ln, I'm going to put 8.0. Okay, because here's some principle which we'll also illustrate by some example. Whenever you put, if the key value has not existed yet, that means we're adding a new entry. If the key already exists, that means we are trying to override the existing entry by some new value. Okay, we'll illustrate these two cases. But now in this case, because ln does not exist in the current map, so that means it's very easy. We simply just add a new row over here, and then we simply put ln as the key, and then we put 8.0 as the value. As easy as that. Okay, so now if you try to say grades.size is going to be 1. Okay, now let's try to verify that. So as soon as you hit it to say step over, you can see now if you go back to variables over here, you can see the way Java tried to present that. You simply say ln will be 8.0. Okay, so they simply say ln being the key value has the being the key has the corresponding value 8.0. Okay, so that's basically like this. Okay, but whichever way to understand conceptually is completely up to you. Okay, I'm just trying to show you both ways. And then, so now if I try to say mark and 7.5, you shouldn't be too surprised. Oh, by the way, if you go back to expressions over here, you can see now grades that contains key ln should now be true because ln is there. However, if I say grades that contains value 7.5, it will still be false because it's only 8.0, not 7.5. It doesn't exist just yet. Okay. So now what I can do is let's add in 2 more. So now if I say grades that put mark 7.5. So now let's do it quickly. So now what I do is grades dot put mark and then 7.5. So that means I'm going to add a new row over here, and then I have mark over here and then 7.5. Okay, and then the next one will be if I simply say step over, you can see that go back to variables, you can see the grades now has 2 entries. So ln has 8.0 and also mark has 7.5. Okay, completely consistent with the iPad illustration over here. Okay, let's do one more. And then as soon as I say Tom and then 6.0. Okay, what I will do is let's try maybe yeah, pink would be fine. So if I say Tom dot, sorry, not Tom dot. If I say grades dot put, and then I say Tom 6.0, I believe. Let's double check. Okay, 6.0, and then the consequence of that would be I will just simply try to add a new row over here. So that'll be Tom and then 6.0. That's what I have. Okay, so after this, so now if you say grades.size, it will simply be 3. Okay, hopefully that makes sense to you. Let's try to do some assertion over here. Okay, the first one. Okay, so now you can see we do have 3 entries. Entry number 1, entry number 2, entry number 3. One thing to note, you can see that the order of the entries which are between Eclipse and my iPad Illustrator is kind of different. You can see I got Tom, followed by Alan, followed by Mark. So it's not really according to the chronological order of the entries being inserted. On the other hand, the way I do Illustrator, it is Alan was inserted first, and then Mark, and then Tom. The order of the entries does not matter for the hash map, because the only way you will actually, the critical way of using, the critical way for you to get access to the map entry will be using the key. So that means the entry order does not matter. Okay, so this view over here and this view over here are completely the same. Okay, just the order of presenting the entries are different. As long as each key has the right corresponding value, we are fine. Okay, so now let's try to go over a few assertions here. First of all, size. Grade.size should be 3 because we got 3 rows over here. Alan, Mark, and Tom being the keys. And then let's just do one here. When I say contains key, so we do contain, in the left column we do have Alan being one of the keys. Of course, that will be true. And also, now let's see how we can understand this line here. So we have a method called get. Okay, get simply means we want to pass a key value over here. Remember, keys are used for search purposes, which means given any key value, if the key exists, it's going to uniquely identify an entry in the map. In this case, it's going to uniquely identify this particular row that has Alan being the key, and then we get the corresponding value, which is 8.0. That is why you can see grades.get. What should be the type for the get method? The way to understand this is when it's a grades.get, because we know that when we first declare HashMap has the value type being double. So you can think about whenever you say grades.get, it's going to return an object of type, the value that we used to declare, which is double. And then we say this double value, which is 8.0, equals this value here, 8.0. Just make sure they're consistent. Okay, so this is to make sure not only that it contains Alan as the key, but also the associated value for Alan would be 8.0. Okay, it's doing this assertion here. And then you can see we just do the same thing for Mark and Tom. Okay, I'm going to leave them to you. Okay, it's very easy to see. Let me just put to you one more thing. If I go to expressions over here, what I would do is I will show you this. I would say grades.get Alan. Okay, and then I'll simply put this expression here, and then it's going to give me basically a double object, right? Because we declare the value to be double. If I expand it, it's telling me value is simply 8.0. Okay, so it's a wrapper object for double class. Okay, okay, let's now go over this assertion, and then until I hit this particular line over here. So now I say grades that contains key Simon. So Simon does not really exist as a key, does it? In that case, so that means Simon does not exist. So that means I will simply put an exclamation mark for logical negation. But now, if I go to the next one, when I say grades.get Simon, and Simon is not an existing key, let's just try that over here. Add a new expression here and put it here. It will simply return null. So that means if you try to search for some key which actually does not exist, the corresponding value simply does not exist. So just null. Okay, and the logic goes this way. Okay, so even when I say grades.get Simon will be null, when I say grades.get Jim will also be null because they don't exist in the table just yet. Okay, that's something, it's a special case for you to know. Okay, so let's do one more thing over here. Remember I talked about 2 cases for the put. So far, as we put Alan, Mark, and Tom into the table, you can see at the time I put Alan into the map is simply empty. So Alan was not an existing key. At the time I was trying to put this entry over here, Mark was also not an existing key because I only got Alan in the map. At the time I was trying to put Tom into the map, also Tom was not an existing key because the map also only contained Alan and Mark, right? So these 3 insertions into the map simply means I'm trying to add new entries into the map. So now let's try to call the same method over here, but you can see Mark is an existing key. How do I know? Let's try. Go to expressions over here. You can say grades dot contains key, and also here I can say mark. Okay, you can see it's simply true. And you can also see from the illustration here, mark it indeed is an existing key. It's the key for some existing entry that's being added. So now when I say grades.put mark and then 5.5, what does that mean? This is how you can understand it. Okay, let me just put it here. Okay, I will put it in a new line. So when I say grades dot put, and now I have mark over here, and then 5.5. Okay, so what does that mean here? You can see mark is an existing key. What we will do is we'll identify which entry it is, which is you can uniquely identify a single entry over here, and then we're going to put 5.5 as the new value for this particular entry, which means we're going to overwrite this value here to be 5.5. That's all we do. So no new entry has been added. We're only modifying the existing entry if the key value is an existing key. Okay. So now let's go back here. So now as soon as we do that over here, what you will see is, first of all, let's go back to variables. If you click on the grades map, you will see mark has now got 5.5. Before it was 7.5, but it now has been modified to 5.5. Okay, and as for Tom and also for Alan, their grades stay the same. Okay, so now if you try to see the assertion over here, if I try to see Alan is still in the existing key and his grades is just the same as before, which is 8.0, and also Mark for here you can see used to be 7.5, but now it has been modified into 5.5 because of this line over here. Change that to 5.5, and also for Tom has now remained the same 6.0, which was also the case before we tried to modify Mark. Okay, and now Simon still does not exist in the map. So if you try that, it's still not an existing key. And also if you say grades.get, Simon will still be null. Okay, just the same as before. Okay, so now let's have a look at how we can iterate through the hash map. Basically, you can see the way we iterate through, there are two ways to do it. Okay, conceptually. Approach number one and approach number two. Approach number one, what I can do is I can just go through the key value one by one. I can go through the key value Alan and then Mark and then Tom. Okay, that's one way to go. And as soon as I get a key value for each iteration, I can ask the map what's the associated value for this particular key. That's approach number one. Approach number two, we can go through the entry one by one, the entire entry. So approach number two, the first iteration, I can get access to this entry over here. For iteration number two, I can get access to this entry over here. And for the final iteration, I can get access to this iteration. So entry by entry, either key by key or entry by entry. Okay, let's see exactly how this can work and see which one you prefer. Okay, both way works. Okay, so now the first way, so let's say I want to calculate the total grade points. Okay, for example, you can see I want to say somehow the first entry has grade point 8.0, the second one has grade point 5.5, and the third entry got grade point 6.0. I would like to add them up together and get a total grade point being 19.5. How do I do that? Okay, so very similar to how we did it for the array list, but for completeness, I will also try to illustrate to you. Okay, what I will do is I will try to go for a new page over here, and then let's illustrate that. Okay, again, let's review what we have. Okay, apparently this is the diagram we had. Okay, I'm just have a new page for you. So this is how we declare. Let's talk about declaration. So we have hash map, and then the key type is simply a string, and the value type being the grade point is of type double. And then we say the grades is assigned to some new object over here. Okay, so now again, this is the key and this is the value. Okay, now let's see the first way of iterating through. Okay, let's see the first way. Okay, I'll simply write it down. Okay, approach number one. Approach number one, we're going to go over key by key. Key by key. So we have the for each loop over here. So we don't really use a conventional loop where you got a loop counter. It doesn't work. because the order of the entries does not matter in a map. So we cannot simply just go over like by indices 0 to size -1. It doesn't work that way for map. So now we say for. So now let me just write it down for you. Okay, so we're gonna need to have a column over here. Okay, and then we're going to have the map name, which is grades. Okay, let me just I need a little bit more. Okay, there's a method you should know. Grades dot key set. Okay, simply call this. So apparently, if you just see the literal meaning for that, it's going to return a set. In the case of grades over here, it's going to return a set with Alan, Mark, and Tom. Okay, let's just let me put it as an annotation for you. The key set over here is going to be a set with Alan, Mark, and Tom. So these are the 3 keys over here. That's what the keys I will return to you. If you have a map with 100 entries, it's going to return 100 keys, right? And then what should we put on the left hand side over here? Let's see how exactly we can do that. So now, what's the type for the key? Well, it's exactly declared over here. So that means we can declare the key for each iteration to be, I can say maybe name. Any name you like for this particular variable. It can be called name, or it can be called string s, or it can be called maybe students. That's also fine. As long as the variable name does not clash with any existing variable in the same scope, then we are fine. Okay, again, it's really crucial. There are 2 things over here. One is the string type over here corresponds to the key type over here. And the second thing is over here, the key set method you have to know how to call. Okay, so these are the 2 critical points. Okay, that means for the first iteration, and let me just say, for each iteration, you can actually use the students. The student is going to be assigned to some key value from the key set, right? The first iteration may be Alan, and then second iteration Mark, and the third iteration Tom. If you just want to print out the keys, the key value will be sufficient. If you also want to get the corresponding value for this particular key, what you can do is you can just say grades dot, remember we have the get method, right? And then just pass the value for the students. So this is how you get a key, and this is how you get a value for each iteration, right? So that's one way to iterate through the map. So that's exactly what you would see in the code over here. So we declare each key being of type string, which correspond to our declaration of the key for the hash map over here in the very beginning. And then we say that the key comes from the key set. And by the way, over here, for the colon, for those of you who actually learned about discrete math, the colon over here corresponds to the symbol membership. You can think about key set over here is returning a set. And we're saying for each iteration, the student is just going to be a member of this set over here. Okay, conceptually, that's what that means. Okay, and then we're gonna say, for each one, we're gonna say grades.get the name. For the very first one, let's just try to see, just write a random. Okay, let me put the breakpoint over here so we can go directly to here, and then we'll say step return. So that way here, let's go through the 3 iterations. Okay. If you move your mouse over the grades, it also shows you the map entries over here. You can also explore them. So now we got Tom, we got Alan, we got Mark. Again, as I said before, the entries order does not matter. In the case of Eclipse, it's going to go through Tom, followed by Alan, followed by Mark. In my case over here, we're going to go over Alan, followed by Mark, followed by Tom. The same thing. The aggregate value for the total points will be just the same. Okay, so now if I say step over here, okay, so now let's see the variable. You can see the name is now Tom, the very first entry, Tom. And then let's just go over here. Okay, go to expressions over here. I can add a new expression here. I can say what's the name, Tom, and then I can see grades.get name. That would be some double object, which is 6.0. And then total grade points at the moment is simply 0. We haven't executed line 51 for the first iteration yet. But as soon as we do that, you can see total grade points has now been changed to, over here, 6.0. Okay, it's being added. And now let's say step over to go to the second iteration. You can now see back to the expressions over here. Name has now become Alan. Used to be Tom, is now Alan. And then the corresponding grades.get name, which will be the corresponding value, grade points for Alan, which is 8.0. So now in a moment, you can see total grade point is 6.0. As soon as we execute this line, it's going to be added the value for Alan's grade points, which is 8.0. Let's try that. As soon as I say step over again, so now it's going to be 14.0, right? It's being added. Okay, let's now go to the last iteration. I think we got Mark left. So now go to the third iteration, you can see it's Mark over here, and then see the expressions over here. The corresponding value grades.get Mark will be 5.5. Okay, so now as soon as we execute this line, you can see back to variables, the total grade points has been changed to 19.5. Okay, that's how it works. So the approach number 1 is very straightforward. You simply have to know how to call grades.keySet. Okay, it's a method for you to use. And then you should know how to declare the type for the key value for each iteration. In this case, simply go back to how you declare the hash map at how you declare that to be. In this case, the key value should be of type string. That's why I put string over here. Okay, and then go through one by one. Okay, so now if I step over again, so now I'm exit from the loop because I finished all the iteration for all the 3 entries, Alan, Mark, and Tom. Okay, let's go back here. And then this assertion is going to pass. And when I say assert equals, it's a good practice to say sometimes for double value, it may not be 100% precise for the computer to calculate. So I will just give some tolerance to say the actual return value from your code can be plus or minus 0.01 as tolerance. Okay? It's just a common practice for you to do assert equals on double values. Okay? Especially for complicated calculations, your value may not be exactly the same as what's expected. So we can have some tolerance, 0.01. It's a reasonable approximation for the actual value expected. Okay, let's go to see the second one over here, approach number 2. Okay, again, let me just go to do that over here. It's going to be very, very similar. Okay, let's just, for completeness, let's do it. Let me use a different color here. So approach number 2. Number 2. Okay, it's going to be entry by entry. Entry by entry. Okay, let's write out the code, which is a very similar structure. Okay, again, I'll say for over here. Okay, and then I need to say some variable over here, and I need to say some type over here. Right, and then I have my colon here. You know, let me leave a little bit more space because in this case I need a little bit more space. There's going to be some type over here. There's going to be some name of variable over here, and then I have the colon corresponding to membership. And then over here I say grades dot. So now rather than key set, it's going to be another method called entry set. Again, you should just know how to call this method, and the rest will be very easy. Okay, so now let's try to understand this. The entry set over here is the new method you should know how to call. Entry set. Let's think about what entry set really is. Okay, it's going to be a set, and where each member in the set is going to be an entry. Okay, each entry is simply a single row in your table over here. So now in our case, let's just put it down. Okay. So now what I will do is I'll write down what the set should be. So entry set over here. So now the first entry will just be Alan 8.0. I'll just say Alan equals 8.0. Okay, I'll just follow the eclipse notation. And then the second entry will be Mark 5.5. 5.5. And the third entry will be Tom 6.0. So I put Tom here equals 6.0. So that's the entry. So this is the first entry, second entry, and third entry. First entry has the key and the value, key and the value, and key and the value. Okay, each entry has the key and the value as opposed to just the key in the first approach. Okay, now how do we declare the type for each entry? Okay, so now first of all, let's declare the name of the variable. That's much easier. Okay, so what I would do is I will go back here. Let me use here, and then what I would do is I can go for you can call the entry, or you can call let me see how I call that in the Eclipse. I just call them entry. Okay, let me just call it entry then. Okay, you can call it anything. You can call it E or entry. Let me call it E, which means you don't have to be constrained by the name you can put for the variable. Let me put it E. So now, how do we declare the type over here? So now there's another class you should know how to use. Okay, as you if you see from the Eclipse over here, there's one class that we import, which is Java utility package map.entry. So this is entry class we have to use if you want to use a second approach to iterate through the hash map. So over here, what I'll write it down for you, and then I will explain to you how you can understand it. So what I would do is I would say entry class, because I already imported it, entry, and entry is also part of the Java collection, which is also generic. And if that's generic, for you to use it, you just have to use angle brackets. Starting with angle brackets, ending with angle brackets over here. And now each entry is going to contain the key and the value. So now what should be the type for the key? Well, you can look it up. It's going to be string. So I'll put string over here. And then what's going to be the type of value? Well, it's going to be double. So I'll put double over here. So that's how you put down the declaration. Okay, again, let me summarize. So now the new type for you to know is called entry. Okay, as opposed to the key type string in the first approach. Okay, entry. And then how do I know the type for the entry? So now I should really look at, for example, over here, the key type is string. So that's why I put string over here. And the value type is double. So that's why I put double over here. Okay. So now I declare entry, and then put the key type and put a value type. And then I put a variable name for the entry for each iteration. So for the very first iteration, E will be referring to the first entry. For the second iteration, E will be referring to the second entry. And for the third iteration, E will be referring to the third entry. Okay, again, the order of iterating through the entries does not matter. For Eclipse, it's going to be slightly different from what I show over here conceptually. But overall, since we only want to calculate the accumulated grade points, so the value would just be the same, the result. Okay, and of course, inside over here, what I can do is, inside the loop, I can say E is of type entry. Okay, so now what I can do is I can either say entry. Okay, let me just see what I use over there, so I can also show you. You can either say get value or get key. Since we want to calculate what's the grade points total, so we only need a value. But over here, you can either say e.getKey, in which case for the first iteration is going to be Alan, second iteration will be Mark, third iteration is going to be Mark. Okay, I can also say another one. I can say e.getValue. And now in this case, the first iteration is going to be 8.0, second iteration is going to be 5.5, third iteration is going to be 6.0. Let's verify that. Okay. So now, of course, for the first iteration, the key value over here and the value over here must be consistent, right? So when I return whatever this is, it must be the key for this corresponding value. That's what I meant. Okay, let's see that from the debugger. Let me go back here, and for the very first iteration, okay, let me just again put a breakpoint over here, and then I would say step return. Okay, let's see the first iteration. Step over, and then what I will see is entry over here, the first entry, in which case it would just be Tom. Okay, the entry itself is Tom 6.0. If you expand the object structure, it shows you the key is a string Tom, value is a double, and then it's 6.0. Okay, let's also see from the expressions over here. We want to see how the E is going to change. So first of all, I can see E over here. Okay, not E, entry. Okay, E is only for the iPad, so I'll put entry. Okay, entry over here, as we see over here, key and the value. Okay, let's just open that to be handy. And then I will say entry.get key, and which is Tom, entry.get value. In this case, is a double, which is 6.0. Okay, so now let's focus on 1, 2, and 3, these three expressions, and see how they change as we go through to the second iteration. For the first iteration is simply Tom and 6.0, which is consistent with what we said over here. Tom, let me see here. So the first iteration is going to be Tom and 6.0, the first iteration. Okay, so now let's go to second iteration. Step over, and then now over here you can see that over here the entry has now been Alan with the value 8.0, and then entry that get key will be Alan, and entry that get value will be 8.0. That's exactly the second iteration over here. So this is the second iteration. Okay, second iteration. And then one thing to note, you can see now before we try to execute line number 58 in the second iteration, the total grade points is only 6.0, only added from the Tom's grade points. We haven't added Alan's grade point just yet. So as soon as we execute over, it's going to be 14.0, adding by adding Alan's 8.0. Okay, so now when we go to the last iteration over here, if you go there, expressions, we can easily predict that it's going to be about Mark. You can see for the entry over here, for the variable, for the loop, key here is Mark, and the value here would be 5.5. Okay, and then for the entry that get key would be Mark, and entry that get value would be 5.5. Okay, so that's exactly the last iteration over here that we are talking about. So we got three iterations to go through all the three entries, entry by entry, for the second approach. Okay, and if you execute this line, we'll see that now total grade points will be just as before, 19.5. You can see these two values agree. Okay, they are completely equivalent, just different ways of iterating through. Which one should you use? As you can see very easily, approach number 1, you can only get key by key, right? If you only need a key value, that's fine. But if you want to get a corresponding value, you must call the get method in order to get a corresponding value. On the other hand, if you're using the second approach, since you're going through entry by entry, in this case, in order to get a key, you can say entry.get key. You don't have to say grades dot key set, right? And if you want to say entry.get, you want to get a value, you say entry.get value. You don't have to say grades.get and then a key value. You don't have to say that. Okay, so these are the two different approaches for you to see which one to use depending on what you need. But now you learn both. Okay, let me just stop this and let me finally just to run the JUnit test to make sure everything just passed. Okay, you can see a green bar over here, and make sure you switch. So currently we are in the debugger perspective. Switch back to Java. Just click on Java over here. So now we're back in here. Okay, so that's about some basic usages for the HashMap. So go over that and make sure you understand that conceptually. Hopefully you can easily adapt the two approaches for iterating through the HashMap in your application.